manipulation. Okay, insert, update, delete, drop. Okay, okay. Now today we're going to learn about constraints. Okay, so let me just create a new underscore query and I'll select school here. Okay, today's topic is constraints. Then we're going to learn about schemas and uh, constraint foreign key constraint same only. Schemas and table partition. Yes, these three topics today we will learn. Okay. Okay. So first we'll see what is constraints. Okay, I'll go through the PPT. Okay. So so what constraints does is okay, it enforces rule. Okay, so when does this happen? When you create a table. Okay, so this is during that time when you can add the constraint. Okay, stating that you enforce a rule on data. Okay, to maintain accuracy and integrity. Okay, so that is
Suren, you are not audible. We
Hey
can't hear you.
Surendra, from last I think 5 minutes or more than 5 minutes, your voice is off.
Okay, now I'm audible.
Yes, sir. Now you are audible.
Okay. If you're not able to hear, at least let me know, guys. See, Rajesh called me and informed me. So at least you guys keep a. Okay. Okay, fine. Okay. Now this is the command that I was writing. So whenever you insert any columns, you have to write this, and then you have to followed by values. Okay. So values again, it will take a parameter something like this. Okay. Now what is the course ID? So I'll just mention my course ID. I'll say 0. So what did I mention? Course ID serial number. Okay. So it will take only integer. Okay. 0, I'll say 711. Okay. Some code. Okay. And course name. Okay. So I'll say Python. Okay. Next, course fees. Okay. Now you see the condition that I have written here is course should be greater than 0. Okay. What if I say uh, 0? Okay. Let's see. I'll show you the difference. Okay. And the last one is course code. Okay. It has to be unique. Okay. So, and it's a varchar. So there is a chance I can use like abbreviation Python. Okay. PY. Okay. I'll say PY 711 with the course ID. Okay. Okay. Now you see insert table. Uh, insert table courses. Insert table courses. 1 minute. Did I select everything or not? 1 minute. I'll save this file also. I want to save this. Otherwise, today's is constraints. SQL. constraints. Okay, so 2026 escape. Okay, okay. So insert into. Okay, now I'll run this command. Let's see. Now you see new row for relation course violates check constraint course fees check. Okay. Why? Because I said it should be greater than 0. I just intentionally added 0. Okay. So it says it violates the check constraint as per the rule. Okay. And it is failing. What if I say greater than 0? I'll say uh, 499. Okay. Okay. Now it's inserted. See. Okay. If I run this command select statement, I see 711 Python 499 py71 is my course. Okay, I'll add another one 712. Okay, I'll say data engineering. Okay, and the course fees is same, and this one is data D712. Okay, some course code. Okay, now I have two entries here, course ID and this. Okay, and the name of the course, and then course fees. Okay, and I have the course ID which I have created. Okay, now here if you see course code is unique. Okay, it says unique, course code should be unique. Now I'll just add something here. Okay, 713. Okay, the course ID, and I'll just mention here Power BI. Okay, 499. I'll mention the same thing. Okay, we need to validate whether it will take or not unique, because it says unique. Okay, and this one we have already said, and we'll check also not null. Okay, we'll check this also. So these are the conditions that will test it now. Okay, now again see duplicate key value violates unique constraint course. This is courses means the table, and which key? Course code key. Okay, where is course code key? Last one. So that means DE712 is already there. It cannot take a duplicate value. Okay, so I'll just mention this Power B. Okay, Power BI 713. Okay, so it's done. Now we have three entries unique. Okay, you can see all unique, unique. Okay, my fees for fees, did we add anything? Only thing is it should be greater than 0. Okay, and if you mention unique here, check codes. Okay, and then unique, what happens? This 499 I cannot use. I have to use 599, 699, something like that. Okay, so be careful when you are designing your table. Okay, sit and spend some time to understand what data it should capture. Okay, so if you just create something, it will, I mean, create a lot of duplicate values. You will end up with cleaning your data. Okay, all the time. So best practice is use constraints at the beginning when you're designing a table, so that you will not see any changes. I mean, duplicate value or null values and all. Okay, now we'll spend some time on course. Okay, it says not null. What means you cannot leave that as empty. Okay, but in my example, I'll leave this as empty. Okay, I'll say 714. Okay, I'll leave it empty 499, and just assume it's a tableau TB TB 714. Okay, I am intentionally leaving this as blank. Okay, it took it. Why? Because I gave a space here. Okay, if I don't give a space, it should Okay, it says wireless courses primary key. Okay, so this means 714 is already there. Okay, 714 is already there. Okay, now if you want to delete, how you gonna delete? Delete. Okay, uh, delete star from courses where course ID equals to 714. Okay, error, delete from courses where syntax error. Okay, delete instead of delete, I would say. Okay, so I'll mention the all the columns here. Okay, where 714 is my target. Okay, syntax error at course ID. Delete course ID from courses where course ID is equal to 714. COURS course ID. It's correct only. Uh, 1 minute. Delete should work. From table name. Okay. Instead of this, I'll say delete from courses where this one. Okay. Yeah. Okay. So you cannot give star and all. Okay. It will not take. Even drop is dropping in the entire table. Yesterday we have seen, right? Okay. Now if I run now courses, now I should be, yeah, that entry has gone 714. Okay. Now I will add power or I'll say tableau. Tableau 714. Okay. Okay. So it has inserted those data and we'll check. Select start from courses. I'm not selected the entire thing. Okay. Now you see. So I have 4 entries. Okay. All unique. Okay. Condition is for this is above this. Okay. You can mention the condition also. Okay. Course fees is greater than uh, uh, 499. Okay. Greater than and okay, less than less than uh, 999. Okay. If you add this condition, what happens? The course phase will travel between 499 to 999. Okay. That's a condition that you are writing. Okay. You can play around with these commands. Okay. With for some other table and just play around and see how this works out for you guys. So this is clear, right, guys? Constraint, the rules that we are writing for a table for the first time when you create. So you can write all these, okay, all these condition, and then you can create your table. Okay, so let me check the table students. What data do we have? So I have these two. Okay, so I'll say drop table students. Okay. Okay, drop table. So it is done. If I run now students, what happens? You see the difference here. Select star from students. What happened? Student does not exist. Yeah, student does not exist. Why? Because when we use the drop command, it will delete the table and as well as the schemas. Okay. If you want to delete a particular row, okay, so you use a statement called SQL statement called delete from courses, where you need to give a pattern here, where clause. Okay, you pick any one column where name looks like uh, uh, Rajesh, or name looks like Sai. Okay, first name and last name Reddy, something like that. Okay, based on that you can remove the duplication by using this command. Okay, so I'll do one thing. I'll create student again. uh, okay, so create table students, ID, serial, varchar, email, age. Okay, now you see I'm writing a condition here: age integer type, check age is greater than 18, enrolled on date, default is current date. Okay, so when I write something called default current date, it will pick up today's date. Okay, we'll see this example also. Okay, if I run this students, I'll just copy. Okay, now I have a dummy schema here. Okay, skeleton. Student ID, name, email, age, and enroll. Okay, now we have to insert a data to check the validation. Okay, so how am I gonna do this? So I'll just copy this insert one. Okay, I'll make it changes. Okay, insert into students. Okay, student, and we have something called student ID. I'll just make those changes. Student ID, then I have name. Okay, third one is email. Okay, email. Next we have age, and last one is enrolled. Enroll underscore on. Okay, so these are my column names where I want to enter some values now. Okay, now as per this I will add student ID. Okay, because it's a serial, so it has to take number. So I'll simply give uh, 001. Okay, and the second one is name. Okay, I'll say Ajay. Okay, name Ajay. Third one is email. So I'll say Ajay Kumar at gmail.com. Okay, this is the email address. Okay, it has to go in quotes. Okay, age. Now, what is the condition that we have written for age? It should be above 18. Okay, I'll add 17, comma. After age, enroll date, I will leave at is because it will take the current date. Okay, let me check and run it. Okay, now it says insert has more target columns than expression. Insert into student age. Acha, enroll. I see date. 1 minute. Date. Current date. It should take current date. So perhaps you meant to reference a column students dot name or the column students dot age. Students dot okay. Uh, I close this. How many entries are there? One, two, three, four, five. One, two, three, four, five. So it is not taking enrolled on. Okay. So it should take.
Maybe we have to put the date there because date default current date. Okay.
It should take a date, current date. 1 minute, I'll just check on this. Uh, yeah, I don't need this because enrolled on it is taking current date, so I have to leave this. Okay, so 17. Okay, new row for relation, constant student age check. See, now we are doing age check. What we have written in our condition, it should be above 18. So it is stopping here. It is not allowing me to populate. And you can see here current date, it is automatically picking up here. Okay. When you say current underscore date, it automatically picks up from your system date. Okay. So it is, I'll say 30. Okay. Done. Okay. Now if I run this, I can see a record here. Okay. So 001 Ajay, email address 30 and date you can see. Okay, my bad. Okay, I don't have to add here after age the enrollment. So whenever we say default current date, it will populate. Say tomorrow if I add one more entry, so it will show 4th to 2026. Okay, so here year comes first, then month and day. Okay, so you can interchange that order also. Okay, when we do this manipulation and all, right, data cleaning and all in SQL, we will learn on how to do that. Okay, with the Netflix data set that we will practice later. Okay, so this is one. I'll just constraints are very important, guys. Okay, because if you know the fundamental here, why we are using constraints, how we are using constraint with the various checks, that we are populating the data so that your data will be unique. Okay. Now here student ID is a primary key. Okay. Here you can see PK, primary key. Name must always have a value and email must be unique. Okay. If you see here, unique. Okay. If I say Ajay 123 name, okay, and he is also using the same, but it will not take. Okay, because I have mentioned here unique, because email has to be unique. Then only you will have a golden records here. Okay, which means I mean the data is like a golden category. Like I mean there is a concept called medallion architecture where we divide or distribute data based on silver, bronze, silver, and gold. Okay. If your data is unique in the table and it has all these constraints that you are adding, that means we consider that as that data as a golden data or golden truth data. Okay. And age must be at least 18. Okay. Age must be at least 18. And enrolled defaults to today's date if not provided. Okay. So that is what I was trying to show you with the example. Okay. Now, second topic that we have is schema. Schemas in Postgres SQL. Okay. Now, what is schema? Okay. Schema are logical containers. Okay. These are logical containers for database objects. Like if you see table right now, you see a table here. Okay. Now you see a table here. We have two tables. Okay. Now, if I create a schema, a logical container, it's like a folder. Okay, it's like a folder where you will be tagging all this work, tables and views, functions. Okay, why? I mean, what is the purpose here? Is they help organize and maintain large databases. Okay, that is where we create these schemas. Okay, now what are the benefits of schemas? It avoids conflicts, naming conflicts, okay, and provides security boundaries. Like for example, there is another. This is see if you see here, this is school. Okay, now I have a college here. Okay, in college also, if you see, I have course ID. Okay, so now what will happen here? See, course is there, enrollment is student is there, even in school is there. Okay, now if I create a schema, okay, so what I can do is I can maintain those boundaries. Okay, provide security boundaries. Okay, and you can enable the modular design. Okay, so that you will go to the proper logical folder and then you will query and retrieve the data. Okay, so I'll show you one example. So how do you create? What is the syntax? So syntax is create schema. Okay, create schema. I'll say university. Okay. Okay. So I have created a schema called university. Okay, sorry, not here. School. Because if you see, I have selected school here. Okay. Now you see, I created a new schema here. Earlier we had only one thing called public. Okay. Whenever you want to add another schema, you can add something here. Okay. Under school only or under university. I mean, I should have done this as university. Okay. Under university, you have school, you have college, you have medicine. Okay. So you can create different schemas and you can maintain a table. Okay. Now here what is happening is first thing is you have a security boundaries. Okay, you will not club with this and this. Okay, So your table sitting here in under university will be unique, then public. Okay, and it will avoid also naming conflicts. Okay, even if you have a table student there here, it will not conflict. Okay, and it's a modular design kind of approach that you are doing it. Okay, so I'll create one and then I'll show you the difference. Okay, now we have already created a schema called university. Now this is the folder I was talking about under schemas. We go public and we create a table and we start working on it, right? But you can create your own logical. You can have a proper naming convention here, like uh, university under that university. Okay, or you can say Ambedkar University. Under Ambedkar University you have law college, then you have engineering college, you have arts college, then you have design college, right? Then you have uh, academics. Okay, student, I mean, elementary schools and all are there, right? So you can create proper schemas here. Okay, so if you practice this, right, you create a dummy and create this, right, you will get an idea. You'll never forget this. Okay, these are very important, guys. In real time, this is how you're gonna see your data there. Okay, under schemas, so you can bifurcate what data you have in university. It's not club with this. How do you do that? You create a schema. Okay, I'll say create table. Okay, now I want to give a reference here, university. Okay, I'm creating a table called university dot. I'm giving a reference here. Okay, I can say courses. This is another way of creating. All this time we were creating create table courses. Now you see here, if you see the folder here, school. Under school, okay, the I mean SQL doesn't know where to create these courses. Okay, if already I have created one here courses, it will say, okay, you cannot create, already table exist. Now here what I am doing is I am giving a reference of my schema here. Okay, that is what I'm trying to explain. University dot courses. Okay, and then I'll close this. So I'll create uh, course underscore id. I'll say serial. Okay, and then I'll say primary key. Okay, this is the first one. Second one, course name. Course name, I will say uh, where care of 100, and it should not be null, not null. Okay, not null. Third, I'll create uh, course id, course name, credits. Okay, credits, I'll say it is integer type. Check credit, credits is always greater than 0. Okay, so this is a table I'm gonna create now. Okay, so I got an error. Course ID, serial, primary. Okay, there is no underscore. Sorry. Okay, it should turn into this color. Okay, should work now. Okay, so it's created now. Okay, now how do you run a command to check a table? Earlier we used to use select star from blah blah blah, and then we used to see, right? Now you have to use select star from university.courses. Okay, okay, now you see I have three tables. Same thing, if I want to insert, I can use the same insert. I'll copy, paste here. I'll say insert into students.courses. Okay, what are the tables we have? Course ID. Okay, so I have to change all these things. Okay, I'll just copy from here course ID, comma, course name and credits. Okay, these three columns I have. So I have to fill. Course IDs I'll take 001. Course name I'll take something called MBA. Okay, and credit. Okay, credit should be minimum 5 credit you will get if you finish this. Okay, but here credit I am doing a check here with 0. So I'll add 0 first. Okay, it should be greater than 0. Otherwise the condition will not applicable. Okay, now it says it gives you the, see in the error message it gives you clearly where the error is coming from. Okay, while it's check constraints. Okay, then what you have to do is immediately you have to go here. Fine. Okay, now if I go to this select star from table I get MBA and fine. Okay, clear guys? Understood this schema? Yes, no? Am I audible?
Yes, sir. Yeah, sir. You are audible.
Okay. Because in interviews and all, they're going to ask these questions only. Okay. How do you have two schemas? How do you access the table? Then you say you'll give the reference of your schema dot with the table name and then you'll access. Okay. And they'll also ask constraint. How do you write a constraint for multiple schemas? You will give a reference with the schema dot with the table, whatever you want to create. Okay. And next one is how much time we have. Okay, we have 4 minutes. I think I'll finish this. Okay, this is table partition. Okay, we have some concept called sharding also, database sharding. Okay, that is when we have populated a data and then what is sharding? I'll explain those concepts later on. Okay. Now see, these are all definitions are all there in PPT. Okay. Uh, create table. This is for foreign key, guys. Okay. So foreign key is a course ID. Okay. From other table you are picking it up. Okay. Reference you are giving courses. See, this is a table name and course ID. This also I'll explain tomorrow. Okay. With an example. Where is partition schemas we are done. So it is for better organization, avoid name conflict, security management. Default schema by default when you install it's a public. Okay, you can create your own schemas and then you can do see something like this academic. I gave a university, right? So you can use something like this. Yeah, this is a command. Okay, and table partition. Okay, so what table partition does is okay, it splits. Okay, the table partitioning splits or divides a large table into smaller, okay, manageable pieces. We call it a partition. Say for example you have a apartment. Okay, we divide the apartment with bedroom, kitchen, restrooms and kids bedroom, right, and your dining table and your sit out. Similarly, when your table has a lot of columns, right, we do a partitioning. Okay, so partitioning in simple terms splits a large table into smaller, manageable pieces while keeping them logically as one table. But the reference will be to one, I mean, to particular apartment only. Okay, say if you have a flat number, say for example, flat number 5. Okay, so what is that flat number 5? That is my table. Okay, in the inside that table, I have bedroom, 3 bedrooms, 1 balcony, and kitchen and sit out and dining. Okay, so these are my columns. Okay, but in real time what happens is you will come across tables that have lot of columns like 100, 200, 300. Okay, you have to spend almost like 2-3 hours to understand what are the tables that you need, what are the columns of data that you require for this project, XYZ project, to work on. Okay, so you have to jot down all those things and then you will create. Okay, so what are the benefits? It improves the query performance. You see, if you have 100 columns, okay, when you say select star from XYZ table, it takes a lot of time to pull. Okay, so that is why we have something called partition, table partition. Okay, so it's a easier data management. Okay, and faster maintenance. That is true. Okay, and Postgres SQL supports range partition. This is for date type of columns. Okay, say for example you have a range. Okay, say for example you have a customer ticket uh, data that you are maintaining in your database, right? So you want a quarter data. Okay, you need last year third quarter Q3 data. Okay, so what you will do is you will mention the date. Okay, some say for example if you are maintaining from Jan to December, so last 3 months. Okay, October, November, December. Okay, so you have to give the range here. Okay, and then you can pull the data. Okay, and list partition is another option and hash partition is another option. Okay, in range is based on ranges of values. Okay, list partition is based on specific values. Okay, I'll show you all this example. And hash partition is it distributes rows across partition using a hash function. Okay, so once we do this hands-on, right, you will get an idea. So what I'll do is I'll create a table, partition table. Okay, 1 minute. Okay, create table sales. I'm creating a table called sales where I'm creating school. Okay, yeah, okay, fine, that's fine. Okay, so I'll create here sales. Okay, so I have 3 columns: sale ID, date, and amount. Okay, numeric, and partition by range. Okay, so I'm already giving an option here. When I'm creating a table, I'll say partition by range, sale date. Okay, so I'll run this. Okay, so unique constraint on partition table must include all partitioning columns. Okay, primary key constraint on table sales logs column sale date, which is a part of partition key. Lacks column sale date, which is a part of partition key. 1 minute. Instead of this, I'll create order. Okay. So I'll create a table called order ID. This is the parent table. Okay. Order ID not null, customer name, varchar of 100, partition by range, order date. Okay. Same thing. There was some mistake in the previous one. Okay. So it is created now. Okay. Second step. Okay, now if you see the parent data, it doesn't hold any data. Select star from orders. Okay. If I run this, you will see no data is there. Okay. And where does this table is sitting? Here. Okay. Now you see when I mention partition by range, you see there is a P symbol here. Okay. So that means this table has a property of partitioning, table partitioning. Okay. So don't get confused with this P. Okay. All this time we are creating just a table. Okay. Now we are creating a partitioning table. So you will see a P symbol here. Okay. That is what I want to show you. Okay. Now next step, what I want to do is I want to create a partition. Okay. I'll say create table. Okay. I'll say sales, create table sales underscore 2025 2025. Okay. And then I'll say uh, partition PRTI partition of sales. Okay. Now this table we have already created. Oh, sorry. This is orders. Sorry. Okay. Sorry, my bad. I was thinking I created a sales and that's where I got confused. 1 minute. Okay. So I'll say order. Okay. I'll say create table order 2024 or 2024. I'll say. Okay. Partition on partition on partition of what is the parent table orders. Okay, which we created here orders. Okay, and then I'll say for values from. Okay, and then I will add date is 2024. Where is dash 01 dash 01. This is one table from two. Okay, then I'll just copy this 2025 one. Okay. Okay. So now we have already created a partition. Okay. We can create another partition called for this is for order 2025, right? We can create order for 2026. I'll just copy this. Instead of 2024, I'll say 2025 order here. I'll say 2025 to 2026. Okay, I'm just changing the table. See the dates. Okay, done. Now I'll insert something here. Okay, right now the table it is dummy. Okay, nothing is there. Okay, insert into orders, order date, customer name. Okay, some values. Okay, now I'll say select star from orders. Okay, let's see. Okay, I have one order here. Okay, if I add some more entries, right, then I can distribute. Okay, for example, I have orders here. Select star, select select star from order 2025. Okay, now you see nothing is there because I have given a range here. Okay, what if I give 2024? Okay, now this is 2024 date, so it is matching, so it is picking up based on the condition. Okay, so you can do a table partition based on the see in real time, right? You will have million of records, million. Okay, so best way is to segregate using date range. Okay, this is how you have to segregate the data, and then you can year data, you can start working on it. So constraint. So today's recap is constraints protect data integrity. Okay, it defines the rules, what needs to be added, what's need to be omitted, right, and what value you can add. If there is a condition that you have already written for age, you cannot add less than that number. Okay, so that is we say protect data integration. Next one is schema. Schema is organize and secure objects. Okay, these are nothing but objects. Left hand side that you see. Okay, objects. These are all objects, guys. Okay, and third one, partitioning. Okay, so partitioning help us to scale large table efficiently. Okay, so I'll add one more, some entries I'll add here. Okay, 2025. Okay, 10101. Okay, okay, I've added. I'll add one more, 6. Atul Verma. Okay, some dummy name I'm adding. Okay, so it says uh, no partition of relation order found for row. Order is equal to 20. Okay, I have to give 6. This is month. Okay, partition key of failing rows order date is equal to 2026. The condition that I gave here, if you remember, create table order. This is 1. Okay, 26 1 1. Okay, so 2026 1 1 before 1 1. It is going beyond that, right? So I'll say this is 1. This is 1. Okay, it should come actually. Hmm. Maybe the condition it is not taking. So what I'll do is 2025. Okay, I'll add this as 0 9 month and some value. Okay, now what I'll do is I'll run this 2024. I'll get only one record. Okay, if I run this for 2025, because I have 2025 two records. Okay, so you can see based on the date value, I can create a partition and then I can query the table. This is one way so that the load doesn't fall on your process and on your server. Okay, so this is this is where we're gonna learn about optimizing your SQL queries. Okay, so this is one of the feature I thought I'll teach you. Okay, see, you can create, see, right now, whatever the table that is there, okay, you can create this command on top of it, existing table. Okay, we have, what is that? Uh, uh, DVD rental is there, no? Okay, film actor, film, I think in film, we have date, I think, 1 minute. Columns, film ID, title, release, length, last updated, I think it's a date only. Okay, so based on this also you can create your partitioning. Okay, see, right now we are not talking about all this where we have 1,000 records. Okay, I will show you. I'll get a dummy data tomorrow, and then I'll share that and I'll guide you guys how to import that data into your database. Okay, and then you can practice. You create a practice called demo. Okay, so you can create something. You can say create database demo. Sorry, demo. Okay, so if I refresh here, I should see demo. Okay, so tomorrow I should have one data with million of records. I'll share it tomorrow, okay, on WhatsApp, and I'll guide you how to import. Okay, you need to click on restore. Okay, and then it has to be in the format of tar. Okay, so there are other option where you can import is backup. Okay, here you can give a CSV, so plain text directory custom. Okay, so here you can give the option here encoding and all. You can leave it as it is. Once it detects the file, it will take that as uh, if I have any database, I have only DVD rental. No, I don't want that. Data set. Okay, I have supermarket sales. No, I don't want to replace file name. Okay, tomorrow I'll show you guys. Okay, I'll take a sample data and then I will help you guys with practice session. Okay, so this is for today. Okay, these three topics I'm pretty sure you guys understood. Okay, the benefit. Okay, this partition basically works out when you have a large data set and you want to partition based on the date columns or categories, like uh, any categories you have, automobile, electronic, chemical, right? You have multiple data set with factories and all, right? You want to bifurcate that, and then based on that you can run your query and pull your data. Okay, and fetch your data. So 1 minute, I'll share this file. This is called SQL constraints. Give me a minute, guys. I'll just share it. You can save all these files somewhere. Okay. Later on, this will be helpful when you want to practice your practice these sessions. Okay. I've shared it. Please save those files and keep it somewhere. Okay. So this is about constraints, table partition, and schemas. Okay. So guys, this is for today. So we'll close this session. We are on top of the hour. I'll close this session. Tomorrow we'll meet again. Okay, at